chapter 6, fundamental of the transistor and biasing. So, and in the last week, as I said before, the biasing means like fixed, okay? The biasing means is fixed. All right, here we go. So, so in the last week, we're gonna learn about the base bias, okay? The base bias. And then today, I really quickly go over the reviewing on the base bias, the transistor circuit, and then maybe one or two sample questions. We're gonna keep learning about the maybe emitter bias, okay? All right, so first one, the transistor circuit, base bias. Okay, so that one is circuit. Usually the register for collector, this is collector, you know, and that was the emitter, that was the ground, and register for the base, R sub B here, that part is like bias. So the transistor consists of the three leg, the collector, base, and emitter. So for the transistor circuit, the base bias, they do not have register in the emitter side because they can be changed. All right, so from here, we can draw the current. They say I sub B, definitely passing through I sub B. We're gonna call it as I sub B as well, and that was V sub CE. That is the voltage between the potential. This is the voltage between the collector and emitter. Okay, and from the circuit we can you know, the remind of you. Okay. And then that was the I sub E, and that was I sub C as well. Okay, I'm gonna just point out here. There we go. All right, so we learned before I sub E is equal to I sub B plus the I sub C. Okay, and I sub B times the beta. It depends on the books or lecture. We're gonna call it as the DC gain for the transistor. That was the same for the I sub C here. Okay. Any questions so far? No. Okay, good. So now we can find the I sub B. So how can we find the I sub B? I'm gonna rewriting here. V sub CC divided the V sub BE for the second approximations minus V sub E, like this one here, register of the base side, and then we can find it because V sub R sub B is I sub B multiply R sub B here. Okay. All right. All right. So, and then we learned before that one was V sub BE 0.7 volt. Okay, for the second approximations. Okay. So from the original circuit for transistor of the base bias, we can also redrawing V sub CC like this one. This is the R sub B, you know, that was the R sub C. C point, that is the D point. This is a diode silicon here. Okay, that was what? E. And that was V sub CE. That is ground. Okay. All right. That's very important. Yeah. All right. So, and also from the transistor circuit of the base bias, we have also learned about the two things. What? This is the load equations with Q point for B, oops, I'm sorry, the base bias transistor. Okay. All right. All right. So now load equations I sub C saturations and then V sub CE. Oops, I'm sorry. V sub CE, the cutoff. Okay. Sometimes off. So load equation, I mean, if we want to find the load equations, we needed to find I sub C saturation part and also V sub CE, the cutoff, the current, the cutoff, the part for the V sub CE in the base bias transistor. So for the base bias case, the transistor circuit, oops. Okay, right there. All right, right there. Oops. It's right there. The load, the equations, we have to the 2 point, as I said before, x-axis V sub CE and y-axis, the collector current here. Writing right here, okay? So to find the load line, okay, that is the linear, the load line, we needed to find I sub C saturations and V sub CE, the cutoff. So to find this one, I sub C saturations is we can find V sub CC divided the R sub C. What is the V sub CC? Supply voltage, just right there. Supply voltage from the collector side, okay? R sub C. That is the register for the collector. So right there, okay? To find I sub C saturations for the case, the base bias transistor circuit, we can calculate it V sub CC divided RC. And then that point is V sub CE off here, sometime cutoff. That was what? Same as V sub CC. Okay. Now we have to know about the Q point, the equations, Q point equations. So how can find the Q point, the equation? So that was the I sub C and then V sub CE. So maybe I sub C, we have already the we have maybe already, you know, I sub C is equal to beta sub I sub B, and the I sub B, we can calculate it V sub CC minus V sub R sub C and R sub B. Okay? And then the V sub CE, would definitely we can calculate it V sub CC minus I sub C times the R sub C. That is V sub CE. Okay. All right. So some point that was V sub CE and that was I sub C. They can moving on the line of the road line. So that was I sub C and V sub CE, like this one. Okay. All right. Any question?
So the spot where they meet is the key point.
Yeah. All right. So we'll try for one sample exam. Okay. The page 21. I think you have it printed out, right? Example 2, the page 21. So I'm gonna drawing for you. V sub CC 15 volt and R sub C 1.2 k ohm here. Okay, and R sub B 690 the kilo ohm here. This is the E point, C point, B point, like, okay. So the question is, what is V sub B? And then what is I sub B? And then what is I sub C? And then what is I sub E? And what is V sub E? And what is V sub C? And what is V sub CE? And what is P sub D? And then what is I sub C saturation? And what is for V sub CE, the cutoff? Okay. All right, just 10 minutes. Okay. What is the V sub B? Okay, so from the circuit, there is a second approximation, you know. Second approximations, V sub BE, it's right there. 0.7 volt. Are you agree with me? It's right there. V sub BE 0.7 volt. That's right there. But we can, you know, the V sub BE mean V sub B minus V sub E, because the definitions of voltage is the potential between the 2 points. For this case, V sub B minus V sub E. Okay, V sub B minus V sub E, V sub B minus what? 0. Why? Because go back to the circuit, the V sub E is 0. It's 0 to the ground. So now V sub B, D is what? 0.7. The answer is 0.7. Okay. All right. The question 2, what is for I sub B? So maybe I sub B, we learned before, go back to the previous one, just like this one here. So I sub B is equal to the V sub CC minus V sub BE divided the R sub B. Okay. So one more time, V sub CC minus V sub BE, the divided what? The R sub B. So that was the V sub CC from the circuit, 15 volt, minus V sub BE, 0.7 volt, divided the R sub B here, 690 the kilo ohm. 690 kilo ohm. So maybe after calculations, we're gonna 20.7 microamp here. Okay. Any question? Okay. All right, good. So the next one is what is for the collector current. The collector current we learned before, beta times the I sub B. The beta is 75 and I sub B we have already calculated from the previous questions. So that was the 20.7 microamp here. Okay. So after calculations, okay, after calculation, 1.55 million. So some students has really similar the mistake before the unit. Okay, we learned before milli, the 10 to minus 3, micro, the 10 to minus 6. Okay. All right. So now the question 4, what is the emitter current? Very easy. Why? Because the we learned before emitter current I sub C plus I sub B, and that was 1.57 million. Okay, maybe I'm gonna skip the calculations by using the calculator because I have already the print out the resolution as well. All right. So the question 5, what is for V sub R sub C? What is V sub R sub C? V sub R sub C, right there. The voltage drop after passing currents through the collector register. The V sub R sub C is I sub C times R sub C. I sub C times the R sub C. I sub C times R sub C. I sub C, we have already calculated before, and R sub C, they are given from the circuit. So R sub C, 1.2 K ohm, and the I sub C, we have calculated 1.55 milliamp. Okay, 1.55 milliamp multiply R sub C is 1.2 kilo ohm. Okay, 1.2 kilo ohm. So the finally after calculations, you're gonna 1.86 volt. Okay, 1.86 volt. And the questions are V sub C and V sub CE, same thing, right? Because the emitter, they do not have the register. Some students, maybe I'm gonna show you right there, like this one here. You know, what is the V sub E? What is the V sub E? Nothing, just only line. Like this one, measure. So what is it? Nothing. But between the 2 points, they connect the register. Yes, they have some voltage drop. Nothing. Well, for the real case, they have a loose maybe inside conductor, but maybe for ideal case in our undergrad lab is like nothing, just the line measurement like this one. E point, the ground, 2 point, the what is it? 0, nothing. But like this one, why? There is the register. You see what I mean? So because V sub C minus V sub E, that is the 0. So this is why that was going to 0. So V sub CE is V sub CC minus I sub C times R sub C. Why? Because we're gonna learn before write this one here. So like this one, V sub CC minus V sub RC, that was V sub CE. That's right there. Okay. So go back to right there. Here we go. So V sub CC minus, that means V sub I sub C. I'm gonna skip this one calculations. Finally, 13.14 voltage. Okay. All right. So what is the question 7? What is the P sub D? The P sub D is formula, the collector current multiply the voltage for collector and emitter. They have already, we know before, right? So I sub C, 1.55 milliamp multiply 13.14 voltage. After calculation, I'm going to skip this one, like this one, 20.36 milliwatt. Okay. Okay, so now we have the 2 more. One is I sub saturations. So V sub CE, the cutoff. Okay. It depends on circuit. They have different equations to find the cutoff, the the CE voltage and then I sub C saturation. So for this case, the transistor base bias, V sub CC divided R sub C, that is the 15 volt, the divided 1.2 k ohm, that is the 12.5 milliamp. It's okay. And then V sub CE, the cutoff, is equal to V sub CC, that was 15 voltage. Okay. All right. So we can draw the load line. .55 milliamp. This is the 13.40 volt. Why? Because that was the Q point. Because the Q point, the I sub C, okay, and then V sub CE. So this is why. And then the I sub C saturation is what? The 12.5 milliamp. And that was V sub cutoff, right? So but that part is what? 15 volt. Why? Because that is the V sub CC. Okay, because like this one here. Here. Okay. We have already calculation before. Okay. All right. Any questions? All right. So now we have new circuit. That is the emitter bias of transistor circuit. Okay. I think the printout, the page for the 25 and 26. So I think until today, we have the page 25 and 26. Okay. All right. Now we have the second circuit, that was the transistor circuit. That is the emitter, the bias. Okay, not base bias. That's very important. All right. So the emitter bias circuit, that was V sub CC. That was the R sub C here. Definitely, that was V sub. There's a C point, and that was the emitter side. Okay, and that was the voltage supply, the base part. That was B here. Okay, that was B. That is C. This is E here, and that part plus minus B sub CE. But for this case is one difference, the compared to the base bias. They was the register. Oops. What's going on? Okay, so here they have register for the emitter. That is the one of the difference one. Okay, so for this case, the register has been moved from the base circuit to the emitter circuit. Okay. All right. So step by step. So the question one, from this circuit, from this transistor circuit, we have a different the formula, okay, to find each part. All right. So V sub BE is definitely same 0.7 volt. Okay. And the V sub B is equal to V sub BB for this circuit. Can you see that right there? Here. That's right there. Here. So V sub BB is equal to V sub B. Same thing. But yeah, that was different from the base bias. Don't confusing, okay? And then next one is how can we find the V sub R sub C? I'm gonna writing for you here. V sub R sub C right there, voltage drop, V sub R sub C in the register of the collector side here. So for this one is definitely that was for what? I sub C times the R sub C. Okay. And to find V sub R sub C, we have to know I sub C. What is the I sub C? So I sub C is equal to the beta I sub B. But that was really similar to the current, the passing through the register R sub E, like this one. This is I sub E. That is I sub B. That was I sub C here. Okay. And then same thing. V sub C is equal to V sub CC minus V sub R sub C, V sub CC minus I sub C times the R sub C. Okay, like this one. And then V sub CE is equal to V sub C minus the V sub E. Okay. And then what is for V sub E? It was very simple one. V sub BE minus V sub B minus V sub E. Okay. And that one V sub E is equal to V sub BE minus V sub B. V sub BE minus V sub B is equal to V sub BB, right? So the V sub BB, oops, I'm sorry. Why? Because the V sub B is equal to the V sub BB right there. Okay. All right. And then and also the I sub E is equal to V sub E right there. Oops. V sub E is equal to I sub E times R sub E. Okay. So the I sub E is equal to V sub E divided R sub E here. Okay. All right. And then for the emitter bias, the distribution power is like same. I sub C times V sub CE. Okay. But they are different one, important. Yeah, I'm gonna have the red one here. So for this case, I sub C saturation current, the formula is different. They adding to the register of the emitter over V sub CC. Okay. And the cutoff V sub CE voltage, same. This is the collector part, the voltage supply. That is also very important things. Okay. All right. So one more time. There's a reminder over you. All right. So that circuit is for oops. That circuit is for the emitter bias transistor circuit. Why? Because compared to the base bias, they moving register from the base part to the emitter part. So they adding to emitter register in the between the ground and emitter side. So for this case, definitely V sub BE, same the 0.7 volt, and the V sub B is equal to what? Same as the V sub BB. That's right there. Okay. So that is like same thing. All right. And then V sub R sub C is equal to I sub C multiply C. For this case, as I said before, I sub B is all right. So for this case, the I sub B is very small. Okay, just right here. Very small. So well, this is why I sub C is almost equal to I sub E. So how can we find the I sub E? So maybe I sub E is equal to B sub E divided the R sub E. Okay. Hey, professor, how can we find the V sub E? The V sub E is V sub B minus the V sub BE. Okay. Here, for this part, I'm gonna red one. That's right there. So V sub B minus the V sub BE. So that was the V sub E. That's right there. Okay. So I strongly recommend you have to read the books, okay? After back to home. It was not easy to understand just only from class. Okay. Just practice as well. So all right. And then the V sub C, that's right there. It was the V sub CC minus the V sub RC. Okay. And V sub CE is equal to V sub C minus V sub E. V sub C and V sub E, we have already calculated, we have already know formula from the previous one. And then finally, the V sub BE is equal to V sub B minus V sub E. That is the one of the to find the V sub the BE. Okay, V sub B and V sub E. Okay. So for this case, as I said before, they are different for I sub C saturation and V sub CE cutoff compared to the emitter bias. For this case, V sub CC divided R sub C plus R sub E. And then the V sub CE cutoff is equal to the V sub CC. Okay? Same thing. So they are same thing. The drawing here, this is I sub C, 0, V sub CE. The load line, linear one, that point, I sub C saturation, 0. That one, 0, V sub CE, the cutoff. Okay, that point. So we know the 2 point, we can draw the load line. And then the Q point here, that is I sub, I'm sorry, that was V sub CE and I sub C. So V sub CE, we have already the calculate before, V sub C minus V sub E. And I sub C is similar to I sub E here. Okay. And I sub E, we can calculate it, V sub E divided R sub E. And, the V sub E, we can calculate it, V sub BE minus V sub B. Okay. All right. Any questions? Yes, I know you are still confusing because we learned before the base bias. Now for today, the emitter bias. Some of them same equations to find for each answer, but some of them is different. So after finish the lecture, you can go back to your home. You have to just writing. How can we find I sub B, I sub C for each different, but two different circuit, the base bias and emitter bias. The base bias, the only register connect to the V sub CC to the base bar. And then the So emitter bias is the resistor moving from the base to the emitter side. Okay, so just in mind of you. Okay, all right. Any question?